For millennia, all over the world, the vast majority of people answered the question, how did human beings, animals, and plants come into existence? By saying they were created by God or gods. Indeed, the concept of accidental creation was considered ludicrous. It was self-evident to everyone, even the village oaf, that complex biological organisms required deliberate design. In stark contrast, today outspoken university professors boldly proclaim that deliberate design and sentient guidance were not involved in the creation and evolution of life. Indeed, they are strongly opposed to any mention of deliberate design in general, or God in particular. Of course, some scientists believe in God, but this is a private belief. Academia as a whole regards the open expression of this belief in the classroom as taboo in the extreme. Instead, biology textbooks at all academic levels now teach that we are simply the product of a series of accidents. This is taught all over the world today. So we see a radical shift. For thousands of years, all over the world, people recognized that human beings and plants and animals were designed, created by God, or God, demigod, some sort of God, some divine creation. Wherever you are, China, Russia, India, South and North America, Africa, it was always like that. But that changed. Now it's all different in the last 100 years. So what we want to explore now is, how did this happen? Well, it occurred by the rise of science in Europe, accompanied by the widespread belief that science is more reliable than Scripture. The first noteworthy theory of insentient creation, accidental creation, or unguided evolution, was due to a French scientist named Lamarck in the late 18th century. But Lamarck failed to provide a comprehensive mechanism for insentient creation. So few European intellectuals of that time took Lamarck's theory seriously. However, in the middle of the 19th century, Charles Darwin provided a detailed mechanism, namely mutation and natural selection, survival of the fittest. Darwin's theory of evolution sparked intense debates among late 19th century scientists. But by the early 20th century, Darwin's theory had prevailed, thereby dominating the thinking of Western intellectuals, with the rest of the world soon following. So that's how the shift occurred, is Darwin presented such a strong case, which was not initially accepted. In science, there tends to be a conservative element, so when you come up with a new theory, the supporters of the old theory tend to reject it and argue against it. So that's what happened with Darwin. It was an uphill struggle. But he made such a careful analysis and did such careful analytical work and presented such strong evidence that he won. He actually won the day. And so by the early 20th century, everyone was believing, or the majority of scientists, and the official view of academia in the early 20th century is that Darwin's theory is essentially correct. An unproved element of Darwin's theory was the widespread belief that the process of random mutation and natural selection was fast enough to create novel biological adaptations within the absolute time constraints imposed by the fossil record. This belief persists in full force today, with a modern variant of Darwin's theory known as the canonical paradigm of unguided evolution, which is random mutation, natural selection, and stochastic genetic drift, as explained below. Radiometric dating of the different strata of the fossil record imposes an absolute time constraint on all evolutionary theories. This is very important. A theory of evolution does not have infinite time. In particular, it must, if it says that an evolutionary transformation requires a time that's longer than the age of the Earth, you can immediately rule out that theory. It must be wrong. Now, there's something even more precise, though, than that, is radiometric dating of the fossil record, which has been highly fine-tuned over a century, the entire 20th century, and now is highly accurate. So radiometric dating of the different strata of the fossil record imposes an absolute time constraint on all evolutionary theories. It's worse than the age of, you don't even get the full age of the Earth. In fact, the evolutionary transition that we will be dealing with, involving a specific protein that I will introduce, had only 15 million years. And I will show that the amount of time that mutation, natural selection, and stochastic genetic drift would take to make that evolutionary transition is 190 billion years. That's 10,000 times greater than the 15 million year time period imposed by the fossil record. So basically, this constitutes a novel paradigm for analyzing Darwin's theory that didn't exist before. It's just available now in the 21st century. You don't even have, or rather, unguided evolutionary theories, which do not invoke deliberate design, do not have the entire age of the Earth. They have only what's allowed by the fossil record. That's how powerful the fossil record is. Because the fossil record is a snapshot of the history of life on Earth. When the dinosaurs lived, when mammoths and saber-toothed tigers lived, when Cambrian trilobites lived, when different forms of creatures that have been on the Earth, especially multicellular creatures, since the Cambrian explosion 540 million years ago, that's been well detailed and worked out and well dated again and again by potassium-argon dating and by uranium series dating. You have independent methods which confirm each other. And on top of that, you have the Puranas, which are based on divine revelation, something totally different. No radiometric dating involved there. It's totally different. But it confirms it. That's why radiometric dating is one of the more solidly established facts of science, because it's confirmed by an utterly different methodology, namely the Puranas, which are based on divine revelation. So you have all evolutionary theories must be measured against the fossil record, and they have only as much time for a particular transition as the fossil record allows. If a theory requires a period of time t that is thousands of times greater than the maximum time allotted by the fossil record, then this theory is false. Very simple criterion. And how do we know how large that time is that a theory requires to produce a particular evolutionary transition? That we know by using well-established mathematical formulae of population genetics. That's what population genetics does. And we will describe this in great detail as we go along. Since this analysis of the canonical paradigm of unguided evolution is based on a protein molecule known as the S1 opsin, which mediates blue light vision in primates and humans. Humans are the most advanced form of primate, but all of the primates have an S1 opsin molecule in the retina, which is blue sensitive to blue light. So you see blue, red, and green, human beings see, because they have these various opsins in the retina. We will focus on one opsin called the S1 opsin, which is for blue light reception. Since most readers are not familiar with the technical aspects of protein molecules, we will now provide a brief essential background. This is necessary because protein evolution is what we're talking about. It's the whole name of the game in the argument that I'm presenting. So it's all based on protein molecules, which are not difficult. You just have to learn a little technology. The function performed by a protein molecule depends on which amino acids are in which positions in the protein. The only function of the S1 opsin is to detect ultraviolet light or violet light or blue light according to which amino acids are in which positions in the protein. For example, A114G means that the amino acid known as alanine, abbreviated as A, at position 114 of the ancestral UV light sensitive S1 opsin has been replaced by the amino acid known as glycine, G, in the human blue light sensitive S1 opsin. Just a little technical nomenclature, but you have to know that. Just like if you want to repair your car, you have to know various technical things like a spark plug and a camshaft, rocker arms, fuel injectors, turbochargers, etc. The numbers signify the amino acid positions in the chain of amino acids that constitutes the S1 opsin, and the capital letters are the abbreviations for the various amino acids. So again, a protein is a chain of amino acids, and according to which types of amino acids are in which positions along the chain, the protein performs a certain function. In the case of the evolution of the amino acid sequence of a protein, which is what we're dealing with here, which provides no fossils to be dated by radiometric dating of the fossil record, scientists know when, in terms of millions of years ago, a specific amino acid has been replaced by another amino acid in a specific location in the protein. They know this by using what's called phylogenomic data, calibrated by the fossil record. See, the fossil record deals with bones and artifacts and fossils. That's what we mean. So if you have dinosaur bones, you date the stratum in which they appear, like the Cretaceous, and you find out that they're 100 million years old, early Cretaceous, for example. That you do is rather straightforward. You just date the stratum, how many uranium atoms are in a particular stratum, and how much a decay product of uranium, namely lead, is there also. And you can use the standard equations of radiometric dating to determine the age of that stratum. Or you use potassium-argon, the ratio of potassium to argon, using similar equations with a different decay rate. So that's all very straightforward stuff when you're dealing with bones embedded in the strata. But we're dealing with a protein and with amino acid sequences. These do not leave record in the fossil record. They do not leave a tangible record because these amino acids are 1 billion times smaller than your body. They're not like big bones that are easy to observe. It's very hard. There are a few examples of DNA or protein molecules from millions of years ago that are still intact, but that's very unusual. So in this case, scientists use what's called phylogenomics, which is the study of evolutionary relationships using genome scale sequence data rather than just individual genes. The genome is the sum total of all the genes in the DNA in the organism. So genome scale sequence analysis is far superior to simply using individual genes, because now you're taking into account a large number of genes in the organism. So, I mentioned that the latest version of Darwin's theory, the canonical paradigm of unguided evolution, is based on random mutation, natural selection, and stochastic genetic drift. So, because most people don't know what that is, I'll explain. And the easiest way is a scenario. Imagine a race of antelopes in which 90% of the population members could not run faster than 30 kilometers per hour, and only 10% of them could run 40 kilometers per hour. One day a virus infected all of the fast antelopes, and within a few weeks all of them had died out. The only surviving antelopes were the slow type. Thus, the fast-running genotype no longer existed in the population. Since the shift in genetic makeup had eliminated the faster ones, the genetic makeup is said to have drifted from the former makeup to the current makeup. This is what is meant by stochastic genetic drift. And another name for stochastic is random. See, these are random events in the sense that they're not strictly determined. It could be like viruses are invading the population of antelope. You don't know where the virus, we don't know what created the virus or where it came from and or how it got into the population of antelopes. Those are all, in truth, nothing is actually random. There are always a set of causes for everything. But the underlying causes may be so complex that it's impractical to try to deal with them. For example, enormous numbers of air molecules are constantly colliding with one another. To determine the position and trajectory of each air molecule from moment to moment, is impractical. So physicists use large-scale concepts to characterize the atmosphere, such as temperature and pressure. This is the thesis of a branch of physics known as statistical mechanics. So that's classical physics. And as far as classical physics goes, everything has a cause. Whatever happens, which is quite common sense. If you knock over a water bottle from your table, it fell on the ground. Someone asks, why did the water bottle fall on the ground? Because you knocked it over, not because it was random. There was a cause to it. Randomness is only invoked when the underlying causes are too complex to characterize easily. So, but it's always understood in classical physics that there is an underlying cause for everything. But then a new and bizarre theory came along recently in science is 100 years ago. It's called quantum mechanics. It seems to have overturned that. So now we need to analyze, because many people will say that my claim that nothing is random and everything has a cause is refuted by quantum mechanics. Because according to the orthodox formulation of quantum mechanics, things happen without a cause. Crazy, completely crazy. But anyway, let me explain how that craziness came into physics. Empirical evidence, such as the famous double-slit experiment, forced the founding fathers of quantum mechanics, especially Niels Bohr and Werner Heisenberg, they were forced to conclude from their understanding of the double-slit experiment that a particle has no position at all until it's measured. For example, if you lose your keys, like you're at home and you lost your keys, you know the keys have a location, but you just don't know which location they're at. You don't think that they no longer have a location because you can't see them. You realize the keys must be somewhere. They have a definite place, but I don't know where that place is. So that's not what Bohr and Heisenberg are talking about. They're talking about at the subatomic level, a subatomic particle has no position until it's subjected to a measuring device that attempts to measure its position. Then all of a sudden a position appears. It's a very crazy system. The reason why would they adopt such a bizarre understanding of reality? Well, the reason why they would do that is because, again, this double-slit experiment, what they find is when you shine light through the double-slit, coherent light, you get what's called an interference pattern on the back, on the screen behind the double slits. So that's why light was viewed for many years as a wave phenomenon. Waves. Light is viewed as waves. But it's also now understood that light is individual particles, namely photons. So if you slow down the generator such that you generate only one photon per hour, then there can be only one photon in the region of both slits at any one time. But strangely enough, what they found is that although there's only one photon per hour, which means there can be no interference between photons, the photon still produces an interference pattern on the screen behind the slits. And that's convinced, and not only photons, but particles with a finite rest mass, like neutrons and electrons and other particles, also do that, even though they're said to have an actual rest mass, made out of matter, not just pure energy like photons. So Heisenberg and Bohr felt that the experimental evidence forced them to accept the concept that a single particle, subatomic particle, interferes with itself. Somehow it's in multiple positions simultaneously, or has no clearly defined position, so it can produce an interference pattern on the slits, even when there's only one particle going through the slits per hour. So that was a decision made by Bohr and Heisenberg. But the interesting thing is, around the same time in the 1920s, there was another Nobel Prize-winning physicist, not as well known as Bohr and Heisenberg, but another Nobel Prize winner named Louis de Broglie, a Frenchman. And he said, well, there's another way to look at it. It doesn't require us to lose a physical description of the subatomic world, because if you adopt the orthodox framework of quantum mechanics, you have no physical picture of the universe, of the subatomic world. You don't know what's going on. Particles have no position. They have no trajectory. They can be in many places at once, all together, but somehow when you measure it, it's only in one place. Very crazy. It doesn't. So the Bohr-Heisenberg formula, or what's known as the orthodox framework of quantum mechanics, does not provide us with a coherent picture, a comprehensive picture of what's happening at the subatomic level. But de Broglie's theory does. In fact, it gives the exact same experimental predictions as the orthodox quantum mechanics. And what it does, but it doesn't involve any bizarre concepts, any counterintuitive and bizarre concepts. It's very straightforward. It has a particle, a single real particle with a real position always, that goes through one slit or the other, and there's a pilot wave that guides that particle. And that's how you get an interference pattern from only one particle in the region of the slits per hour. So it's a very clear conceptual picture of the subatomic world. The particle goes through one slit or the other, and its trajectory is guided by a wave, the quantum wave, which was worked out. This is de Broglie's theory. He got a Nobel Prize, by the way, in physics. It was quite brilliant. It gives a real picture of the subatomic world, whereas the other picture by Bohr and Heisenberg does not. It does not give any real physical understanding. It's totally weird and bizarre. No one can understand what it's all about. That's how the Schrödinger's cat came about. Schrödinger was also one of the founders of quantum mechanics, but he later parted company with Bohr and Heisenberg because he said, this is ridiculous. And his Schrödinger's cat description is meant not to support an ultimately weird and mystical reality, like many New Age people think. Rather, Schrödinger's motive for describing the Schrödinger's cat paradox is to point out something fundamentally wrong with the Bohr-Heisenberg prescription. And Einstein also didn't like it. In fact, Einstein was very heavy. He said, the Heisenberg-Bohr tranquilizing philosophy or religion is so delicately contrived that it provides a gentle pillow for the true believer from which he is not easily aroused, so let him lie there. In other words, Einstein is saying that Bohr and Heisenberg want a quick fix involving some mysticism, but it's not, there's no reason, no compelling reason to adopt it. Then why did they adopt it? So the answer to that is that Bohr and Heisenberg, if you read about their lives, they had a philosophy. They had a mystical philosophy. They liked mysticism and things that were difficult to understand. It makes for more, you get more prestige if you have something difficult to understand rather than something simple and straightforward. So that there's a motive there. They wanted to become great teachers, innovators in physics, changing everything. And Bohr and Heisenberg were very eloquent speakers, whereas the other physicists of the time, like Einstein, were not as eloquent and charismatic public speakers. A charismatic public speaker can make people believe things that are not true, like Hitler. Hitler's a great example of that. So the physicists of the early 20th century did not need to adopt the mysticism of Bohr and Heisenberg. They could have gone with de Broglie's method, and many physicists support de Broglie's methodology. Another Nobel Prize winner named Murray Gell-Mann said Bohr brainwashed a whole generation of physicists, just like Einstein. And other physicists nowadays, like Roger Penrose, a recent Nobel Prize winner, and Gerald 't Hooft, another Nobel Prize winner, have expressed profound dissatisfaction with the orthodox formulation of quantum mechanics, precisely because it fails to provide a coherent picture of the subatomic world, which is exactly what Einstein said. So, in summary, it is a misconception that quantum mechanics forces us to accept the concept that the subatomic world is inherently ambiguous or inherently random. and the concept that the outcomes of measurement of subatomic phenomena are fundamentally random need never have been adopted. So my point here is that there is nothing actually random in the quantum mechanical sense. If any randomness is to be introduced, it's exactly like in classical statistical mechanics, where instead of describing large numbers of air molecules, you use concepts like pressure and temperature, which are easy to measure, because you can't measure all the individual particles. They're enormous. There are billions and billions and billions of air molecules in a square foot of atmosphere. The size of your head, there's billions and billions and billions and trillions of air molecules banging into each other many times per second. So it's not practical to try to chart the exact position and momentum. So there you use a kind of averaging system, which is the essence of statistical mechanics, and you take variables, average variables, that can be easily measured, such as temperature and pressure. In contrast with the stochastic nature of genetic drift, the process of mutation and natural selection is deterministic, which means that, given a precise set of initial conditions, the outcome is determined in advance. That's what we mean by deterministic, as opposed to stochastic. Now, science is not based on belief, it is based on facts. The belief we are talking about is a belief that the canonical paradigm of unguided evolution is fast enough to create novel biological adaptations within the absolute time constraints imposed by the fossil record. The purpose of this article is to evaluate this belief in light of the facts of molecular biology and population genetics, because it's too important to be left to belief and speculation. I believe this, and you believe that, and he believes this. That's not science. Science means facts. So nowadays, due to molecular biology and population genetics, we actually have enough facts to test this belief that Darwin's theory in its modern form is actually going to work or not. We can actually test it. Now, molecular biology is required because the various functions of the physical body are based on molecules, such as DNA and protein molecules. And regular changes over time in these molecules determine the trajectory of evolution. Population genetics is required because evolution involves simultaneous genetic changes, mutations, in many members of a population that interact with each other according to natural selection and stochastic genetic drift. How these changes accumulate over time is determined by the mathematical formulae of population genetics. Now, we'll first deal with the molecular biology. We will analyze the evolution of the S1 opsin molecule. So, the eyes of the mammalian ancestors of primates who lived before 90 million years ago were able to detect UV light, ultraviolet light. The molecule in their retinas that enabled them to detect UV light is known as the S1 opsin. It is a protein molecule consisting of a chain of approximately 300 amino acids in length. Its spectral peak, the wavelength of light at which it is maximally sensitive, also known as lambda max, is determined solely by its amino acid sequence. The S1 opsin of these mammals had a spectral peak of around 360 nanometers, which is within the UV range. Now, the important concept here is that they have actually reconstructed in detail the evolutionary trajectory of the S1 opsin in the primate lineage leading to Homo sapiens. So who reconstructed it? Well, there's a scientist named Shozo Yokoyama, professor of biology at Emory University in Atlanta, Georgia, who is an international, world-renowned expert on opsin evolution. He spent 30 years and published many papers on it. So he's an expert, world-renowned expert. And he reconstructed in detail the evolutionary trajectory of the S1 opsin in the primate lineage leading to Homo sapiens. We will focus on the first phase of this evolution, which was mediated by 3 specific amino acid substitutions in the S1 opsin, namely T93P, A114G, and F86L. As I mentioned earlier, 93 means the position in that chain of amino acids that constitutes the S1 opsin. So T93P means that the ancestral amino acid T has been replaced by the amino acid in the human lineage, namely P. And P is proline. So there are three of them. We're dealing with three specific amino acid substitutions that transform the ancestral UV sensitive S1 into the human blue light sensitive S1 opsin. So these are T93P, A114G, and F86L. Again, the F, L, A, and G, T, and P are abbreviations for amino acids like alanine, glycine, proline, leucine, isoleucine, etc. And each of these amino acids has specific chemical properties that determines what the protein does. So the first phase of this evolution involving these three substitutions took place from 90 million years ago to 75 million years ago. By the way, all this information is in peer-reviewed scientific journals by professors at major universities. So it's considered rock, and it is supported by AI like ChatGPT and other AIs. So this is considered the most reliable source of information. Peer-reviewed scientific journals combined with AIs. So now we will get into the very important details of the reconstruction of the evolutionary trajectory by Yokoyama and colleagues. According to Yokoyama et al., 2014 Supplementary Data Table 1, the T93P substitution shifted the spectral peak of the S1 opsin by 2 nanometers. The A114G substitution shifted the spectral peak of the S1 opsin by 1 nanometer, and the F86L substitution shifted the spectral peak of the S1 opsin by 0 nanometers. So this is important because the function of the S1 opsin is to collect light, and the wavelength of light at which it is most sensitive is called the spectral peak. As I mentioned, the ancestral spectral peak of the S1 opsin was in the UV range, 360 nanometers. But the blue light is around 420 nanometers. Each of the colors, like green, is around 530, and then yellow and orange 560, and red is around 650. The wavelengths of what we see as different colors is based on wavelengths of electromagnetic radiation. So it's very important to note that the individual amino acid substitutions, these three that I mentioned, in the first evolutionary phase, which is the one we're focusing on, each one of these individual substitutions had no tangible effect on the fitness advantage. That's very important because, as we mentioned, survival of the fittest. If your mutation produces a superior genotype, then that more than when the parents who have that superior genotype mate, more of their offspring survive than their offspring of other parents because they're superior. By survival of the fittest, they come to dominate the population. So it's very important to determine whether a mutation produces a fitness advantage or not. That's a key point. Does a particular mutation produce a fitness advantage, or is it what's called neutral with respect to natural selection, meaning it produces no fitness advantage at all? So the evidence given here, supported by direct statements of Yokoyama and colleagues, is that none of these three substitutions individually produced any significant shift in the spectral peak of the S1 opsin. This means that each one of these three amino acid substitutions was individually neutral with respect to natural selection. Only the combined effect of these amino acid substitutions had the power to significantly shift the spectral peak of the S1 opsin, thereby conferring a tangible fitness advantage. One might object that I did not take into account the possibility that the three substitutions individually increased the protein's stability, which would also confer some fitness advantage. So I searched on Google Scholar to find a paper that explicitly addressed this question, but I could not find one. So I put it to Gemini, the Google AI, which responded by saying that, so far, there is no evidence that any of these three substitutions increase the protein stability. This statement was confirmed by ChatGPT, although ChatGPT left open the possibility that future research could support the idea that these substitutions enhance the protein stability, on the grounds that two of these substitutions introduced the amino acid proline and glycine, both of which are known to have the potential for increasing protein stability. So there is no evidence so far that any of the three substitutions increased the protein stability, but there's a possibility that they could have. But if you consider another fact, that the S1 opsin has existed stably in the biosphere for hundreds of millions of years, then there's no reason to believe that relatively recent substitutions in it would significantly enhance its stability. So as far as we know today, which is all you have in science, there's no reason to believe that any of these three specific amino acid substitutions that constitute the first evolutionary phase provided any selection advantage at all. They did not provide a sufficient shift in the spectral peak individually, and individually they did not provide, as far as we know, any increase in the protein stability. So therefore, by all scientific standards of knowledge today, these three amino acid substitutions of the first phase of the S1 evolution in the primate lineage leading to Homo sapiens must be considered neutral mutations. So now, the rest of this video deals with calculating the time required for the first evolutionary phase. Now that we have determined that the three amino acid substitutions are neutral, we can use population genetics formulae to calculate how long it would take for three neutral mutations to accumulate in the S1 opsin. We're not saying they happen all together. Don't make that mistake. They could have gradually accumulated. We're not requiring them to accumulate all at once within one generation. That's ridiculous. They most likely accumulated gradually. So we need to use population genetics to calculate how long it would take for this accumulation. And there are four crucial parameters we will need to evaluate. One is called the selection coefficient that quantifies the strength of natural selection when all three amino acid substitutions have accumulated in the S1 opsin. So, to evaluate that, we don't know what it was, so what we do is we will give the greatest benefit of the doubt to unguided evolution. And we will therefore take a selection coefficient of 0.1, which is very large, rarely seen in mammalian evolution. We only know of a few cases, such as the lactase persistence in Scandinavian populations has been estimated to be of the order of 0.1 for the selection coefficient, which is one of the highest values ever observed in mammalian evolution. The higher the selection coefficient is, the shorter the time required for the canonical paradigm of unguided evolution. Therefore, in order to give the maximum benefit of the doubt to this paradigm, I will assign the selection coefficient, we'll call it sigma, to be 0.1. So now another key parameter is mu, the mutation rate, the single base pair germline mutation rate per generation. So there's another paper, a peer-reviewed paper by scientists named Brevet and Lartilot, who figured out that mu was 2 times 10 to the minus 9th per base pair per generation. Another key parameter is the population size n. So n is calculated by using what's called mean pairwise coalescence time. So the first point is the population genetics parameter we're concerned with is the effective population size, and that is determined by this mean pairwise coalescence time. So using that, it's interesting that Ghaffari and Weissman, who were world-class experts in population genetics said in their paper, 2019 paper, roughly speaking, under many reasonable models of population dynamics, the faster a process occurs, the largest its corresponding effective population size is, ranging from the standard effective population size for processes taking many generations to the census size, population size, for processes occurring in a single generation. So from that, it's clear we need to use the NE that is obtained by mean pairwise coalescence time. I also described that that has been found to be slightly inaccurate. It's 15% less than the true rate, but we can take that into account. So we find that Brevet and Lartilot, 2021 paper, gives NE, inferred by mean pairwise coalescence time, of 10 to the fifth. And the correction factor, which is given by another set of scientists, Cousins et al., 2024, they say you need to multiply that by 15%. So that comes out to 1.15 times 10 to the fifth. Another key parameter is F, the genetic recombination rate. According to Lynch and Abegg, another paper, 2010, page 1411, the genetic recombination rate F is 10 to the minus eighth for the situation in which all the mutations are within the same gene of a multicellular organism, which was the situation of the 3 single base pair mutations that produced the 3 amino acid substitutions within the one gene that encoded the S1 opsin. The universally acclaimed report for calculating the time it takes for the accumulation of these 3 amino acids in high-level peer-reviewed journals is Ghaffari and Weissman, 2019. The relevant formula in this report is equation 27, option 6. Inserting into this equation mu equals 2 times 10 to the minus 9, F, the recombination rate, 10 to the minus 8, sigma, the selection coefficient, 0.1, and the effective population size is 1.15 times 10 to the fifth. So you insert all of these into equation 27, option 6 of Ghaffari and Weissman, 2019, and the result is 190 billion years. Thus, the time t required for the accumulation of the 3 amino acid substitutions in the S1 opsin is 190 billion years. But, as documented above, the absolute constraint of phylogenomics calibrated by the fossil record only allows 15 million years for this accumulation. This enormous 4 order of magnitude discrepancy demonstrates the failure of the canonical paradigm of evolution. Now, I'm also going to show that genetic hitchhiking does not help, cannot reduce the time. I show this on our website in an article called "The Molecules of Life Were Deliberately Designed." I also deal with the idea that structured populations would significantly reduce the time to accumulate these 3 amino acids. So I show that neither hitchhiking nor subdivided population structure has the power to significantly reduce the time to cross from one genotype that the entire population has shifted to a new and superior genotype in which all 3 amino acids have accumulated in the S1 opsin. So that's on my website. It's a little technical, but it's there. Now, it should be pointed out that according to another biologist named Emmerling et al., 2015, research has identified a dozen vertebrate lineages in which the S1 opsin switched from UV sensitivity to blue light sensitivity. Thus, there's likely to be more evidence for the failure of the canonical paradigm of unguided evolution. The reason I'm mentioning that is it's not just one case, the human blue light sensitive S1, but there are many others within the vertebrate lineage. And I have not had time to analyze them yet, but there's a potential for more evidence demonstrating the failure of the canonical paradigm of unguided evolution. So, now we get to the final part, the philosophical implications of the failure of the canonical paradigm. Since there are only 2 alternatives, guided evolution and unguided evolution, The failure of unguided evolution means that the evolution of the S1 opsin must have been deliberately guided. In other words, the S1 opsin must have been deliberately designed via the process of guided evolution. Since design has been established, we are logically forced to conclude that there must have been a designer. Since there are no terrestrial beings capable of manipulating the genomes of terrestrial primates tens of millions of years ago, we are logically forced to conclude that the manipulator, or the designer, must have been a superhuman extraterrestrial. Since the designer's body must be at least as complex as the primates he designed, and since this complexity must be based on discrete material subunits analogous to the DNA, RNA, and protein molecules ubiquitous in all terrestrial bodies with which we are familiar, then we are logically forced to conclude that this designer must also have been designed. It's important to recognize that any material system capable of advanced cognition, whether a biological organism like a human being, a computer made of silicon chips, or a set of electromagnetic fields that interact with themselves, any material system capable of advanced cognition must necessarily have a high information content in order to carry out advanced cognition. And this high information content must necessarily be based on a complex underlying material structure. In order to avoid the logically untenable situation of an infinite regress of materially embodied designers, we must acknowledge the existence of an original, transcendental designer, namely God. So that concludes the argument. I have on the article on my website, when you go down to Our Literature, when you first get to the website, there's a video. Then below that, a statement about what we're trying to do. And then below that, as you scroll down, you do very little scrolling, by the way. You get there real fast. You get to a page called Our Literature. There you will find the references to all the peer-reviewed scientific papers and ChatGPT and Gemini AI references that I mentioned. So all the references are there on my website. In the article entitled "The Molecules of Life Were Deliberately Designed," this will give you the exact references for the important papers that I used to produce this argument. So it's all on my website. I'll give you an example. One of the more prominent papers I cited was Ghaffari and Weissman. So the title of their paper is "The Expected Time to Cross Extended Fitness Plateaus." They publish in a high-level scientific, highly respected journal called Theoretical Population Biology, Volume 129, published in the year 2019. The other major one I mentioned was by Professor Yokoyama. So his paper is entitled "Epistatic Adaptive Evolution of Human Color Vision." This was published in the year 2014, Volume 10, of a highly respected genetics journal called PLOS Genetics. That plus the other references that I use to support my case, all from high-level scientific journals or recognized AI like Gemini and ChatGPT. Everything I'm presenting is solidly established either by AI or by peer-reviewed scientific papers, and all the references are given on that article on our website, which you find, scroll down to Our Literature, you'll find an article by me entitled "The Molecules of Life Were Deliberately Designed," which is essentially a script of what I just read today. Now, I'm very interested in questions. I love to answer questions. I'm happy to hear challenges. You don't have to believe me or accept what I say. I'd love to be challenged. I love to have a nice dialogue on these things. So at the very bottom of the website, there's a place you can click on called Contact Us. So you can send me an email and I'll promptly respond. So thank you very much.